In this particular video, we'll be studying a new model on reciprocating air compressor. So this is in the module 5. So module 5 consists of two segments. One is reciprocating compressor and the other is the nozzle part. So the first part is reciprocating compressor and we are starting that particular module in this particular video. So first topic in the reciprocating compressor is the working principle of reciprocating air compressor. So where these are reciprocating air compressor are used. If you visit our FM lab, you can even see the reciprocating compressor over there. It has two cylinders in it with an intercooler. One is HP cylinder and the other one is LP cylinder. So these reciprocating air compressors are used to increase the pressure of air and store it in a separate pressure vessel where you can use it for the different purposes. That particular stored compressor air is being used for various other purposes. Okay, we shall look how this reciprocating air compressor will actually work. Okay, so now the IC engine is a reverse of reciprocating air compressor. I can say it in a very lame way. So how it is? So if you provide a fluid power in an IC engine, okay, that combustive power, that chemical power is being transmitted through the piston downward, and that will cause the movement of a crankshaft. That means you are getting what? You are getting the shaft power from it. Okay, what are you getting? You are getting the shaft power, which is which you will be measuring by the formula 2 pi nt by 60, is it? So you are measuring by this particular formula. So what happens in a compressor? So you are giving the shaft power to an air compressor. So this becomes your input. Okay, so this becomes your input. From this input, you are compressing the gas in a reverse order. Okay, because of the various strokes, what happens? The air is sucked inside like this first. Okay, because of the stroke of the piston from, that is movement of the piston from top dead center to bottom dead center. So what is dead centers again? So this becomes your top dead center and this is your bottom dead center. Okay, so your piston moves from top dead center to the bottom dead center during the suction stroke. Air is being sucked, or because of the shaft power which you are giving as an input to the air compressor, what happens? Whatever the volume which you have sucked in, okay, entirely will be compressed till the volume of VC. Only a small volume is left over. Okay, so the whole volume is sucked, only this much is left over. So this particular volume is what? This particular volume is VC. Okay, so the compression stroke happens from where? It happens from the BDC to TDC. Okay, so the main important thing you have to remember in this particular thing is you are giving the shaft power input. Because of the shaft power input, what happens? Your air inside the piston cylinder gets compressed. So air inside the piston cylinder get compressed. That particular compressed air is being delivered out. Okay, this is how it works. Okay, so we shall see the process of it. So this is the PV diagram. Okay, just mention it. I forgot to mention it. So this is a PV diagram of reciprocating air compressor with no clearance volume. So this is your clearance volume. What is a clearance volume? Suppose imagine your piston is here. Okay, so your piston is at top dead center. So now here piston is at top dead center. There would be certain volume. There would be certain volume inside the cylinder where your piston cannot reach. So I'm marking it with some annotations like this. So this particular volume in the cylinder cannot be reached by the piston. So this is nothing but your VC. Getting my point? What is VC? So VC is that particular volume which cannot be compressed or where your TDC cannot be reached. So that particular volume is known as the clearance volume. So if there is this clearance volume is negligible, that means your value of VC is 0, then your state points, that is number 3 and number 4, will be on the volume line itself. Because why? Volume 3, that is the volume at state 3, is equal to volume at state 4 is equal to 0. Why? Because your VC is 0. There is no clearance volume. If you are neglecting the clearance volume, then your state points number 3 and number 4 will be on the axis itself. Okay, so if suppose you want to consider the clearance volume, then your PV diagram will look like something like this. Okay, it is you have seen this particular PV diagram in the Brayton cycle also. So this becomes your 1, this becomes your 2, and this becomes your 3, and this particular thing becomes your 4. So this is how it looks in case you are considering the clearance volume. Okay, if you are not considering the clearance volume, the state point number 3 and 4 will be on the axis itself. Okay, so the working principle of the single acting stage air compressor with negligible clearance volume. This is very important, with negligible clearance volume. That's why your VC becomes 0. Okay, that is why your state points 3 and 4 on the axis itself is shown above. It basically consists of a piston rod crank cylinder with valves. The working fluid may be assumed to be a perfect gas. Definitely we'll be assuming it as a perfect gas for all our analysis, further analysis. The cycle completes one revolution of the crankshafts. Okay. Next. So these are the different strokes which I have just explained. 4 to 1 is your suction stroke, 1 to 2 is your compression, and 2 to 3 is your delivery. So 4 to 1, where is 4 to 1? So 4 to 1, this particular process is your suction stroke, where is air is getting sucked inside the piston cylinder. So the main process in this is 1 to 2 there, which is compression, correct? So 1 to 2, which is compression, where it is 1 to 2, so here it is 1 to 2. Remember this particular process, which process? Can you just justify what is process 1 to 2? What is process 1 to 2? Can you justify? So process 1 to 2 can be isothermal, okay guys, it can be polytropic, okay, or it can be adiabatic. So remember, the compression process can be all the three. So it can be iso, it can be polytropic, it can be adiabatic. Any of these three it could be. So generally we prefer isothermal process because it gives the maximum efficiency. So we will try that this particular process, which is from 1 to 2, is of isothermal in nature, where temperature is constant throughout the process. Okay, we will try to make the temperature to constant throughout the process. Why? Because in order to improve the efficiency of this particular thing. Okay, now. So this is about the compression. Okay, it is generally considered as a polytropic, where it is given by the expression as indicated here. It is PV raised to the power of n is equals to constant. Okay, if n takes the value of gamma, so again basics thermodynamics, if n takes the value of gamma, then it is known as a adiabatic process, correct? If n takes the value of 1, then it is known as a isothermal process. So remember all this basics, man. PV raised to the power of n to the constant is a polytropic process. PV raised to the power of gamma is equals to constant is a adiabatic process, and PV raised to the power of 1 is a isothermal process. Okay. So, and 2 to 3 is a delivery, where the air is being delivered from your compressor. The delivery takes place at the constant temperature, okay, as indicated here, 2 to 3. So it takes place at the constant pressure and constant temperature. Because of the opening of the delivery valve, the cycle repeats again as the piston moves downward. So this particular, say, whatever the process we have just discussed, it repeats again just because of the rotation of the crankshaft. Okay, so this is how you can get the basic idea how a reciprocating air compressor will work and how the PV diagram of this will look. And remember, this is the PV diagram without considering the clearance volume. If you are considering the clearance volume, it would be of such kind. It would be away from the axes. Okay, so that is the one thing. And water jackets are provided. All the around the cylinder walls. Why? Because in order to reduce the heat, to maintain the isothermal process, or to maintain the temperature of which it is a constant, so that's why the water jackets has been provided. So this is the basic idea of reciprocating air compressor, working of reciprocating air compressor. So further we will discuss the terminology regarding this in the next video. Okay, thank you.